I will share my screen. Okay. Yeah, most students join. Okay. All right. I already put some new file on our Google Classroom website. You probably can see couple one. First of all, is introduction to the recommendation system. This our main topic today, and then I will go to the Spark and Hadoop installation. I'm asking you to try on your computer, especially on the Docker. I will go through that part, and if you have time, then I would like to share with one of IPYMB is a Jupyter notebook. I let you run on your Hadoop and Spark system and do some practice. And as you can see, I also put the one of called data for Spark. Basically, is the movie recommendation data set that I would like you to download it to your Hadoop environment. So this is something I want to cover. But basically, I think I will make sure that everybody have a system ready, and then you can download the data and to your Ubuntu system. Then you use some kind of command to upload the data to your Hadoop environment, and then you have a data to work with. And that is very important because in the following courses and maybe next week, we were still working on this data. And so I really want you to do some practice on this data set, then you can know how to exactly doing something on your environment. All right. So that's my plan for today. All right. Okay. So I will, before I go to the system, I would like to talk about this topic. It's called Introduction to the Recommendation System. Oh, by the way, as we already know that on May 13 is a day, it's a Friday. We're going to have a meeting in RB 102. So that you will see our EMBA students to present their project to you. So just to remind you, I will remind you this. Okay, just want to make sure that everybody know. So on May 13th, okay. All right, I would like to start to talk about this introduction to the recommendation system, and I will give you the slides. I want to give you a little bit more detail about this work. Okay, give me a second. Let me get my pen. Yeah, I might need to draw something on the screen. So this is any. Okay, I will play with. All right. As you already know, the recommendation system is one of the most common application you can see on e-commerce website. For example, in Amazon.com, when you log in, they actually know who you are, right? Then you choose one of the product, you can recommend you something. So I want to show you some example, and then you can quickly to capture the idea. And today I want to talk about how this listing doing. Here is my Amazon account, as you already think was login, right? And in the first page on the screen, okay, you probably see several different products. And those products, either some of them I buy it before. For example, I actually my wife buy this thing before. And you also see some shoes I'm looking for. Yes, I actually just looking for the shoes on Amazon.com. I mean, probably 2 weeks ago. And some of the children's stuff, I actually buy this thing. So you can see he kind of recommends so many different things to me. You know, maybe he guessed I'm interested in that. Okay. And most importantly is if you buy a click on something, obviously this is one pair of shoes, right? In Amazon.com US, you can see there's so many different functions. And here is the thing. It shows you some shopping trend. Okay, is an introduction. And he also provide you some recommends items. It's really good. As you already know, the customer has some question, there's some recommendation. So that's a very common e-commerce website. They already have it. Here I want to check with one book. I say also PySpark. It's something we're going to learn. I'm choose a book, and I want to choose one of probably interesting book. Maybe this one. Okay. I choose one books. Obviously, it's a sponsor. I mean, they put advertising on it. And you can see there are some information also showing that people can involve together. If I buy this, if some people buy this, okay. Comes out all who buy this, I don't buy this. They call that there's a very typical function that people calculating the things that we wanted to recommend, right? And then this is a very important introduction. For example, this part. I personally like to use this uh, Amazon system to check some, for example, some books and people we really want to, because people review it that thing, these two are very important, or these three items are kind of things people put in together. So this is a very interesting function. Although I am not really want to buy it, but just I want to come here to check is the popularity of a certain area. For example, Spark that I'm just talking about, and PySpark. There's some applied data science using PySpark. It sounds interesting, right? So if I want to learn something, I want to buy some books for my personal teaching. You see, it's very convenient that you go through and check it, and then show you different review and show you some stuff. And that is a very common and very simple, especially for the customer. They already get used to it. Okay, so don't even mention the Netflix. Maybe I can open my Netflix if you want, and I will show you something. It's called the recommendation. For example, when I log in my Netflix account, of course, it is Taiwan, so you will see some in Chinese, of course, and you might see different countries have their own special style. I still remember when I was in Paraguay, so when I log in my Netflix account, they can notice where I am. They just notice where I am. I am in South America, so it started to recommend something in South America, especially for the movie is filmed by the Spanish. So we could see different things and you get different rating in different area. And everything you see here is it already come with a recommendation system. All movie showing based on this different category that they come to recommend something. And to save my time to reach to read to choose. And if you like, for example, there's a very wonderful, very popular Japanese cartoon, and you will see. I can also give it a like. Right now, it's just very simple, not even rating. They just give it lighting and something, and show everything in detail. And it can be used in so many areas. So today, I would need to introduce to you some of the very fundamental knowledge we need to know about the recommendation system. Okay, let's go back. Yeah, well, I would like to play the movie for us, but I'm sorry, I probably cannot do that. All right. Okay. So as I was saying, recommendation system, they try to offer, maybe you're a newcomer, you just you go to the newspaper, so many different news. So which one I would like to, the system would like to recommend to you? That's very important. And there have been some retailer, online retailers, it's just what I just said, e-commerce website. So which items I wanted to come into your customer. Usually the customer have the way they will kind of searching on the website, right? So you Google it, maybe you go to Amazon.com, you just type in the keyword and some information that want to search. And that's one way, right? But another way is called recommendation, that you just log in and you will see something over there. I didn't really search something. I just show on the first screen, and the web page is portal. They already know you come in, and since we would like to log in, then they will know which items are wanted to come into you. Okay, and that is very important. All right. Oh, by the way, the TA will take attendance, so you're supposed to be on the system. Okay, so be aware of that. Okay. Um. Yeah. I see somebody leave. It's some kind of weird. Okay. You're not supposed to leave. Okay. All right. So there's different technology we actually use it. I want to explain that. For example, called content-based system. Um, for example, it basically examines the property of the items you want to comment. For example, in Amazon.com, they take a look on the detail on the items description. And item description, there are some information, right? So check with that and try to find who is the one I would like to recommend this to a particular customer. But how can that do? Of course, they have some historical data. For example, like my Amazon account, I've been using for more than 10 years. I keep buying some books, shoes, for example, when I was in US, and my wife actually buys something for children. So they already know these guys have the family and he has children. How probably he can guess how old he she is because we're buying shoes for children, and then we know is it for girls, is it for boys, and then he can exactly know some information about me. Although I didn't provide that. And similarly, the Netflix is one of popular system we mentioned several times in these courses. And the Netflix also try to understand what is a particular customer, what kind of movie or what kind of drama, what kind of items they want to recommend you. So that's why everybody log into the Netflix system is that for the top one, top two rating. Other things it might be in different categories, they might be different. And that's we all relate to the content base. That means we talk about the items, we talk about movie, we know the movie, what kind of actors, what is the director, all the information. And another one is called collaborative filter system. It basically wanted to combine items based on the similarity measures between the user or items. So collaborative filter systems has two major types. One is a user-user collaborative filter. They try to find if it is a customer and which customer has a very similar viewing preference on items or that, for example, like movie, they wanted to recommend something to people that might be have a very similar taste. Okay, the item collaboration filter is a very similar idea. Just checking with if it, which items are have been buy by certain people has a very similar similarity. So that they can recommend to customer. So I want today I will talk about this technology first and let you give it some idea. just like I say that necklace, right? We already talked about it several times. I don't want to repeat this because original is come with is like this mailing system, but right now it's all on the on demand online, so it changes business model. And let's take a look on a very simple utility matrix. It's about movie. I actually copied this from one of the textbook. It's a very entry level books, but it's useful for me. For example, as you see one of table here, and that show the information here is A, B, C, D. Here is basically for customer, for user. And here are 7 different movies. HP is Harry Potter 1, Harry Potter 2. I didn't watch all of those movies, but there's a Twin Life, and maybe it's a Star Wars, different movie. And you see this table actually contain some information about rating. How they rate the movie. For example, a customer they watch Harry Potter 1, he rate number rate 5 minutes is quite good, and rate 20 lives 5, Star Wars 1. So that is we call it utility matrix, and you actually represent the ratings of a movie on different scale for each individual customer. So we start with these items. Here is the things. What is our goal is try to predict the blanks in that utility matrix. As you already see, there are several different space as nothing. That means that a customer never watches Star Wars 2 or Star Wars 3. Maybe they watched it, they just didn't put it rating, maybe. So that is a matrix. So you can see this matrix is very sparse. Sparse means that it's a lot of space is empty. And the empty that means it's called blank, and we want to predict the entries. So, but here's the things. Do I need to predict all empty items on, I mean the spots on the utility matrix for all of the items? Yeah, probably not, because it's only necessary to discover some item. Especially we want to discover some item that we think that will rating very high. But of course, that's a very simple reason, because you probably don't want to recommend something to me and predict it. I would probably rate them just 1. You don't want to recommend the movie, the item to me, right? If you can't want to predict my particular rating for the item, of course you don't want, you just want to recommend something I would probably rate very high, right? So that's why that we don't need to go to all the thing blanks, but we really need to find something. Okay, so and here is it's also not necessary to find an item with highest expected, but only find the largest rating. Yeah, here's the thing. So we want to find a subset, and it probably will be very high. Then we can use that knowledge to recommend several different people. Okay, because every single people have its own tastes and purpose, but we just want to find a big group. Okay, and so how to do that? So, but think about some example here is the original. We our data is very scarcity, and how to use it is particular for TV networks or movie and theater. It's basically you got a lot of those. It's kind of scarce commodity that you have some item you wanted to customer. But there are some website that also called near zero cost as a dissemination of information. For example, here is the things. You go to a website, you just put on your items. This on website. The cost is relatively low, So here, just want to have you have a more chance to suggest something to customer and compare with the movie theater. And what it means, usually if you have a chance to go to movie theater and you want to watch a movie, and the movie theater, most probably in Taiwan, most popular movie theater probably can just provide you like 5 or 6 or even 10 different movie you want to watch, right? But if you go to Netflix, it's not only 10 you can recommend. You have maybe thousands of different movies you can recommend. So that is a majorly, we want to make sure that you understand the abundance. That means that we got really good big list of items that we can recommend. And for that kind of service provider, they would really want to recommend. They want to have like a recommendation system to customer because But here, if you go to the some of service sale space service provider, yeah, we only have 1 or 2 choices. Probably don't need to recommend. Do you understand? You go to a restaurant, if a restaurant have only 2 items you can buy, either one drink and one lunch box. That is not recommended. I mean, your choices are very limited. Probably don't need a recommendation system. But you can imagine that if you go to a restaurant and they offer you a menu and you put it on the hand, oh my God, there are more than 1,000 different items you can buy. Then at this moment, you probably ask the waitress to say, hey, can you recommend something to me for today? If that is the case, like when we say recommendation system, we need it. And here is one chart, it's called long tail, and that is very popular and important. Here is a particular title, rate by popularity. And here is the average number of player we watch. As what's this distribution mean? It's a very long tail. I mean, some movies are so popular, they are is rating top 1, top 10 is very early, and a lot of people actually like to watch those top 1. But if you really have so many different items, then the popularity and a number of players, you can see this trend. I mean, some of things maybe not very popular. Very few people want to watch it. For example, this one. Very few people want to watch it. But that's all the items I have. And, I can provide this online and to fulfill the people's needs. You not necessarily always want to looking for the top 1, top 2, right? But you sometimes you want to looking for some of a movie, some special drama, then you have a very personal reason you want to watch it. And although those popularity is not that high, and the number of people that would really watch it is very low, but since it's on demand service provider that can provide that to you. That is how. That is how the Netflix can compare with the blockbuster. The one of the DVD, movie DVD business store provider, and actually blockbuster is already gone. It's a loss because blockbuster only focus on this part, but the on-demand things they can provide more items and also come with a very, very low cost. So recommendation types have several different kinds. Some is editorial one. Is for example, as what I just mentioned a long time ago, is for Amazon. Amazon actually have some people to review the books and then to provide the comments about books. But right now they use a different way, right? They let the customer review the books and give the comments. That's our project one. And some of the recommendations is actually simple aggregate. So hey, I will provide you the hey, what's the top 1 rating? As you see in Netflix, right? You will see most of the people are watching this particular city or area or country that what they like. and most popular reason upload. So right, that's a recommendation type. And sometimes it can be tailored to individual customer, right? For individual customer, and we call the customization, customize, provide. So for example, like Amazon and Netflix. So we start with a very simple model. Then as you can see, utility matrix, and here is the number of customers. So this is come from C. Oh, sorry, we moved too fast. Come from C, and the items is come from S, right? So basically, the utility function is C times X, so it's a matrix, and everything here is rated, right? So and rating, you can set out the ratings from 0 to 5 stars, and also you can give a real number between 0 to 1. That means 0.99, 0.99 versus 0.5, different rating system. Okay. So that is the utility matrix MSC. So you got C here, you got S here, and you got rating here. So what's the key problems here? You want to get a null rating for matrix. That's the first thing. So you need stuff with one of the matrix, and you want to extrapolate the unknown rating from known rating. Yeah, right. So that is why we need some data processing and data science to study this. And mainly we are interested in the high unknown rating. That's what we're trying to know. And we want to evaluate its extrapolations method. So then here's the last part. We want to check if the commands is really good. So that's an evaluation. So we want to see if we send to the message to our customer, and we have the evaluation and to make sure the customer will like it. Okay. So that's the first part, how we get the ratings. Okay. And there are two ways to get a rating. One way is called explicit. Basically, just simply ask the people to rate it, right? And for example, you have to watch a movie online. Netflix usually they will probably ask you to rate it. Do you like it now? Okay. If you like it, from 0 to 5, give a rating. Okay. But seriously, these things don't really work very well in practice. Because, for example, like me, I watch Netflix sometime. After watching it, I'm not quite interested to put a rating there. I just go on and doing something I want to do. I don't really rate seriously. Although the rating is already very simple. It just asks me I like it or not. So, but unfortunately, I don't really rate any movie I actually watch. So I will need to. So that's the issues that we are not easy to get a rating. Okay. Somebody call me out. Okay. All right. So that's another way, so called impressive way. We're trying to learn rating from the user's action. Although I didn't really write anything, but the system actually still knows something about me. Okay, for example, if I purchase something, then probably just simply we have a high rating. Okay, and but what about low rating? It's tricky. For example, I want to give you ideas to think about. Actually, a lot of data science people, they are scientists and want to create a way. So, for example, here I want to give you an example. That's a real world application. So, I don't want to keep the rate. So, I want to go back to my Netflix. I want to give you an idea. As you know, the Netflix has one thing. So, I'm sorry, it's in Chinese. Basically, here's my list. I usually I prefer to save something for later, right? I save something For example, you go to my list and you can see some of items that I used to want to watch it, but I haven't had time. So this is a list I would save for the future. And that would be very important for land, although I never read anything on that. But here is something that they kind of understand. Hey, this kind of person would like to watch those movie. They're trying to aggregate information about me. And also, as you know, they can record everything about how I watch it. So I want to go back. So for example, I used to watch a movie, but I for the first several couple minutes, and I stopped watching it, and I never come back to watching it. And that also maybe give you a very important sign for them and say, hey, this guy probably don't like it. So they can try to gather information about how I really want, for example, my personal list. And it's similar to Amazon.com. Here has something called, you put it on your checkout basket, right? But you never check it out, right? You never really purchase it. But that would can come up with an idea, say, hey, maybe you like it, just not don't want to buy at this moment, and that give it some information about you for that particular items, right? And that's a very important a way to know more about your customers' behaviors. So here is how to exploiting the utilities. That means that matrix. So key problem is the matrix is sparse. Yes, of course, and of course, not every people lighting. I see is a items rating. The rating is not just a couple points that people really rate it. So because most of people they never rate everything, right? And because of that, then you will face in what we usually call cold start problem. What cold start problem say that means that's a new item to join to maybe on list of a Netflix. That's just new, so no any rating before. And maybe you can say, hey, that's just a new customer join, and we have no any records about him, and so no history. So this kind of a problems we call the cold start problem, especially for the recommendation system. So there's some issue there. And there are different approach to handle that. For example, called content-based, collaborative builders, and some hybrid. Hybrid is basically content-based process, content-based plus the collaborative as hybrid. So I want to talk about this a little bit. So what is a content-based recommendation system? The main idea is you want to recommend items to customers see that is similar to the previous item ratings hidden by C. So its idea is if I buy one pair of shoes before, and I purchase based on my purchase history, and so the system will also recommend something similar to the shoes I just buy, and that will try to guess maybe I would like to buy it. Okay, so that's the main idea. For example, here is a movie recommendations. Actually, do this way. Want to recommend some movie with a certain probably the same actors, director, Jared, and maybe just this particular user just like to watch it. For example, I used to like Tom Cruise very much. As my idol when I was so young. Although right now it's still pretty old, right? I just noticed that. Oh, come on, it's 60 already? I'm not sure, but anyway, any movie he films, I would probably like to watch it, right? So, and if Netflix noticed that hey, this particular actress is my idol, then they try to recommend all of the movie he films and to me. And that's a very simple concept. And website, browse, and news also recommend other sites with a similar item, right? I give you news. Maybe you like a political news. Maybe you like sports news, soccer news about Europe or South Africa. There's a soccer competition, and that would be if you I can know your taste. That way, I will know your preference. That way, it would be easy to recommend something to you, right? So that is ideas. If it has a user like a certain item, and we start to check the profile, items profile, and maybe you can find a user that item profile to build a user's profile, and then start to find if it has animations items that fit into user's profile, then I can recommend to our customer, and that is the idea. So we are not only to build a user profile, the user profile actually come from the items profile. Okay. And how to build this profile is very important data processing, right? So what's the item profile? Oh, there are so many different item profile. For example, the example I just say about movie, and the movie has a certain profile. For example, movie has an order, maybe the actor's title, and some of text is an important word. As you know, in a document, and some image has even take the take, right? Take. You usually use a take to on a certain image that we can use. Okay. So if you want to use that you will notice that hey, all information is all about is the text. So for text mining, you already know one technique called TF-IDF. I think that some students use this on your project one, right? And it's one of the technique we call term frequency times inverse document frequency. I want to give you a short introduction. It's basically come with a two-part TF and IDF. So what is TF? It's the frequency of item TI in the document DJ. And INJ is basically it's an indicator, so don't worry about it. But it's want to know what that particular items, for example, my name's on the certain item document, and they want to find how often, what's the frequency, right? How often the Chao Long Yang, this particular words, the set, have been appears on that one particular document. So we first want to count it. And just because of that, that you have to know, I give you an example when I introduce the Hadoop system, right? I say, hey, word count. Also, word count is so important. And why people need to do word count? Because the word count is something, because we count it, that we are able to calculate this called frequency, right? And since we need to know the frequency, then we're able to calculate TF-IDF. And why we need a TF-IDF? You would just want to know what a particular word is so happen to show on some certain document, and that document can be very wide definition. For example, your blog, your message, your text, or your personal reviews, and that's just what we did in project one. And that is very important. So word count is fundamental a function as a very important for the text mining. So we got a frequency, and here I just want to normalize it. Is you find a maxima for a particular items, particular word happen so in all the document. So we kind of normalize it to discount it for the longer document. Why I want to have it? Some documents are very long compared to one. For example, your report is 200 pages versus a 5-page document, and obviously the longer document, and you have more chance to appear my name probably. That's As just an example. So we kind of want to choose the most longer one, then we want to have a normalizer. So here's a normalization. And what's the inverse document frequency is basically you can see it here. And the N is the total number of documents, NI is the number of documents that mention the particular term. So let's say there's 1,000 different documents, and I want to check if which documents mention my name. Okay, and that my name is NI and N. Of course, if this number is wrong, it's very large. That means very few people mention me. Okay, but if you the 1,000 documents, most of them mention me. Okay, then we got one here. The local number is very close. So here is when we time them out, it's called TF-IDF. We actually try to find accept the words with highest TF-IDF score, and then we want to choose them as choose those terms to create a profile for the particular items. Okay, and that is the fundamental concepts we try to use for the text mining. Okay, and so since we are able to find the TF-IDF, then we are able to use that highest TF-IDF terms to categorize the document. So we have certain number of words with certain percentage of word, and we have some threshold we can need to set. And basically, we want to set and use the word to express a subject or main ID. Think about your language, for example, English or the Spanish, and you want to take a look at news. And there are so many documents like that, right? News, post, or anything. And if you are able to use a certain keyword and to represent the document, that would be very important idea. And some of the document, for example, the academic journal publication, also papers, those academic words, that would suggest that we actually require, not suggest only, it's required for the author to list at least 4 or 5 keywords. And the keywords just want to represent the document, right? And similarly, so that's TF-IDF, all those text mining methods just want to find some particular words to represent the document. Okay, and it has been used quite a lot. And also TF-IDF is not the only one. There are so many different ways to do this. As some of the students in your project, when you use one kind of Python code called word to vector, right? And that's another similar way we try to measure that the document by certain words and use the words and to represent that document, right? By us a vector. Okay. So, and not only the document, some of the data like image, there's areas pixel, and the area pixels have been used, can be represented. Also, we take items by words or phrase and describe the item that were usually very common, right? We used to have the photo website. I used it very much, and although all of the photo I took, sometimes you will ask me to put some text. Okay, and Facebook originally very early times want to create, they can automatically create so many text on one image you put on their system. Especially for the young people, you prefer to use IG, right? I guess you have an IG account, right? Sometimes you post one video or post one images, a photo you just took, and the Facebook IG system, they basically want to create a text on that video or on their items, And why you want to do this? Because we don't know more about you, right? Know more about your posting. Okay. So then once we have profile, then here then we can use the profile to do the prediction. And so the user profile's possibility is we have web average rating for items profiles, and we kind of want to know the variations of a weighting of different from the average rating. Okay, so the thing about that sometimes it's a common variation that I'm not always rate 5, right, for everything, right? If I always rate 5 for everything, I mean no variation, right? It's always 5. But we'll sometimes rate that like different ratings, so they kind of want to calculate that. And there are certain kind of a prediction heuristics. Basically, just given the user profile and items profile, right? We got small c, we got small s, right? Remember our c and s, right? And we want to estimate for that particular c and s, what is a score. And here you can see COS is cosine similarity. And basically, it's one of the measurements they want to estimate the similarity between two items. So we want to find an efficient method to find items with high utility rate. So that is what we try to create. And so similarity measurement is one of the most important functions that you need to use here. And the similarity measure that also have so many different kinds. But of course, I want to introduce to you some simple one. So I want to give an example here, and we can kind of want to learn how this system works. But of course, I just want to mention that this example is very simple, right? It's just a kind of a couple movie rating. So it's just for the education teaching purpose. As you know, the real world, you might face a huge amount of data and a very long and very largest data set that you probably need to handle. Okay, here's a two movie. That's a movie one. There's one movie and there's another movie, and that's people's rating. But of course, you see zero. This zero means no people rating on it, right? And your rating is summarized 0 to 1. For example, you like it or not like it, right? Like it is 1, not like it's 0. Oh, if you want to put like that. And also you see the different way that maybe there's a different ratio. Alpha might be certain ratio, and maybe it's a certain item indicator you can use. So here I want to make sure you understand that. That's a movie one, that's a movie two. And other people, let me several people that put a rating on that. And I want to see if they are similar or not. And you want to do that, then we can actually use the dot product. I'm not sure you learn this from linear algebra, right? You learn the linear algebra. Then basically it's simple. You say 0 times 1 plus 1 times 1, so 1 times 0, 0 times 1, 1 times 1. So you can see only these two parts have the things, so it's comes to root 2. And that is the 12, right? So that's how I wanted to measure that. Then if you want to calculate cosine similarity, then we will consider the angle, because you basically want to calculate the length of each vector. You consider this one vector and another vector, right? This vector. So you can calculate the length of this one, then you can calculate the length of this one, you combine with it together, so you can calculate cosine. And basically cosine is one kind of angles of two vectors angles. And as you know, if this angle is more small, they are more similar. Okay. Of course, if you see the angle, that two vector angle is 90 degrees. They are very, very similar because cosine 90 degrees. You think about cosine, it's going to be 0. Right? So that's a fundamental calculation way. If you know that, then we're able to compare the two movies ratings. Okay, so there are some model-based approach for each user. We try to learn the classifier that can classify item to the rating class. Okay, like by user and not liked by user is some certain indicator, right? And several different technology methods you can use. For example, using Bayesian's regression model, and this is called support vector machine method, SVM. But no matter what, that is kind of is a statistic or machine learning based method that can help you to create a prediction model. And so you want to apply the classifier. The classifier says, hey, that's an unknown blank there. And are we able to classify the particular item to in certain type? Okay. And then we try to find the recommendation candidates. Okay. So that would be used for the recommendation system. Okay. Of course, there are some scalability issues in this model-based, and particularly for larger data set or larger scale, the sparsity. Okay, that is not. But we are now in these courses. We only focus on this introduction. If you are interested, you can look more about the recommendation system model. Then you can learn more. But I'll probably just give you some introduction here. Okay, let's talk about pros and cons. As we already know, content-based. We don't talk about the content, right? Since it's content, we want to know the items, movies, image. So we use a certain way to extract the information from the content and try to find the similarity between the contents. Okay, so then we can classify the items. Then we try to recommend something based on classified items. So obviously, here's some pros. You don't need for data on the user, right? So it won't have a cost problem, a sparsity problem, because there's no rating on app. It's just simply checking the items, characteristic, right? Characteristics mean there's, for example, one pair of shoes versus another pair of shoes, and then shoes the contents. You TF the idea to get the idea. Then you try to find, oh, this shoes as description is so similar to another pair of shoes. So these two shoes similar. So we are able to know, no matter if these shoes have been sold on Amazon or e-commerce.com before, even never, it's new shoes. Then we still can work on that. And also, it is able to recommend user with unique texts, right? Maybe some customers like these special items, but we still can find it because if you purchase it before, then we are able to link it with the user. Do you remember the user profile versus the item profile? Right? Item profile to link with user profile. So just for example, I buy very special coffee beans before. I probably like that kind of taste. And by using this content-based approach, then they can kill text on me, say, hey, this guy like that kind of coffee. If you have that kind of coffee come in, then you can recommend to the customer. Right. And also it can provide some explanation about the recommended item by listing the content feature, the Coursera. That's just why I just give you an example, right? Then now that by using the historical data, they know, hey, this guy like this special tastes of this coffee, this kind of coffee, then they can provide the explanation. And that's good things about content based. But they also have some limitation for this kind of approach. Sometimes you have to understand, find an appropriate feature is very, very difficult. For example, yeah, if you want to take a look at music, as an example, that how do you describe the music? It's tricky, right? Because the music usually come with a different song, different musical items, come with different instruments, and you know that's how to describe items is a bit tricky. Okay, if nobody really do the text, and that means that we are not able to describe. So, and movies also. A movie is usually like 1 and 2 hours long. And how to describe features and different things. It's a 2 hours movie. There's so many items, and how you extract it. Okay, so that's some kind of difficulty. And also, they have some other issues. You might over specialization. That means you probably don't want to, since you already know the customer's profile, then you never recommend items outside customer profile, of course, right? For example, I particularly like one kind of coffee, so you keep recommend those things to me. So you have no way to know more about me. Maybe I'm not only like these things. I also want to like to buy other things. And since I never did this, your assistant don't understand me, so you just keep recommend something to me that are very similar. So that also means that people, our human beings, might have a very multiple different interests. And if you're not able to find it, then you can just, you know, continue to comment similar thing to me. I will feel bored, right? For example, you go to my Amazon.com, then you already see that shoes and some items. Well, I just happen to buy it, and then you just know, oh, I that's the only shoes style I like it, and that kind of color always. It's hard to tell, right? Sometimes I just want to buy another kind, um, but your recommendation would be always quite similar because you know my profile. So that's a limitation of a content base. And for new users, still need to difficulty because new customer, we are not able to build a profile, right? Since we don't have a liquid stock of him or her, and we don't know if you buy purchase something before, then we are not able to build a profile for that. Since we are not able to build a profile for that, so then you usually cannot recommend better. Okay. So that's the content-based recommendation system. Here, I want to introduce another kind called collaborative filter. And collaborative filter is a little bit different. I will still consider user C, but we find a set called D for other users whose rating are similar to C's user. Compared to content base, he didn't really use the rating. He actually used the item or the text or description to describe the items, and then use that description to link build up the user profile. But here is the different. We're fine. Hey, you prefer something similar than if you. That's why I say I read this movie before. Very good and very high. And another customer, they also have a very similar rating behavior like me. Okay. And however, he didn't or she didn't watch that particular movie. I read number 5. So since our similarity there, so the recommendation system would recommend the movie to the, the customer. So basically, we only estimate the user's rating based on rating of a user indeed. Okay, that is the ideas. So if your preference and another person's preference is similar, here will come with a lot of people, right? Here's a lot of people's preference. If you only identify you are similar with the preference, then and they like this thing, and this thing never be watched or used before by this person, then I would comment to him. Okay, that's a fundamental idea. So that's called collaborative because it will come with so many people's help, right? Other people's helps, and then we're trying to do a filter, right? So try to find a similar user. So let Rx is a vector customer rating. Then again, we can still use the cosine similarity measure, right? To measure another people and this rating if they are similar with this guy's rating. Okay. So we can use a Pearson correlation. But here's the one, I just use a very simple example, right? To write these two user X and user Y's rating and try to find the item right by these two customer, then we are able to use no matter what. I just want to buy if your customers a similarity based on their rating. I will skip this calculation, but this is just some example to show you how we use a similarity measure. And since there are so many different kinds of similarity measures, so we are able to use. So just give you an example. So here, just want to say, hey, that's a rating, right? That's just a rating I just showed you before, right? So right now we are able to use it. For example, that's A and C, right? Or A and B, right? And we want to calculate cosine of angle between A and B. So A and B is this one, this one, right? So again, it's only several things. I think this calculate. Sorry, and it's A and B, right? So only this part. So that's what we calculate, and that's the vector's the length, vector's length, right? And the vector's length. So A and B is 0.398, and another one is called A and C. And C, and C is this one and this one. That's a 2. So that's why this bread box will calculate. So we're able to measure the similarity between A and B and C. So we use that one to measure all the customers' ratings. So here just an example that I just kind of want to mention that they can use the normalization rating. So the normalize it. So based on the information, based on this, you can calculate all number. For example, its total is I think it's 10, right? So you kind of average the rating by take an average on that. So the average of this thing, so it's 10 and there are 3, right? So total score is 10 and there are only 1, 2, 3. So divide by 3. So that 3 will come with the average rating of less particular customer A. For A and B and C, we all can calculate average rating. So only differences from direct using this part is we consider the average rating on that. For example, the original 4, even minus the original rating is basically they want to measure how their customers are rating against their average rating. Then we can recalculate the order similarity, and that would be interesting way to calculate. And then since you see a negative, that means opposite direction. That's mean some kind you can measure the differences is not very similar. So again, A and B are more similar based on our calculation. All right. So by the way, I want to make sure you understand this is just an example to calculate these items. So you want to use a rating and compare with the customers similarity based on rating. So that we can do a ratings prediction, right? So I won't go to then this kind of maths, but it basically that's a possibility for prediction items that are access customers access rating, and that N be accept the NK customer. It's not only one. They are most similar to the X. So you think that's a customer code S, and you find a lot of people called N1. That's a K customer, and we make sure they are quite similar. So the possibility for the prediction item X for the customer user that we actually can come from the information you belong to this set and try to find which things this X customer never watched it or never have it before, and based on our groups of customers that rate something that are very high, and this X never watched it before, so we can suggest. And that is obviously the way we will use it for the recommendation and also prediction. So you can actually predict the similarity based on the similarity to calculate. Here, just talk about the concept, right? And there, of course, there are many tricks that can possible. So based on that, the previous example, I actually introduced a user similarity checks, and here is also similar things is called items, but the items is similar, right? As a customer and as items, right? And we compare, hey, this customer's rating if we compare with this one. That's called user collaborative. But there's another way called customer is we consider this way, right? These items have some other people's the rating and compare this item. This is another item, right? There's one item and we'll compare with that. So we can find a similar items. This item is similar to another item. And previous example, I say, hey, this customer is similar to another customer based on their rating. And here is based on rating again is called item similarity. And can use a similar matrix way I'll just use it and to talk about that. So the calculation here just kind of give you a little items. We have used items similarity way we calculate that based on the equation. Okay. So here is I want to check with the example. So but just want to be aware here I put it is this example is a little bit different. Is a C is X, right? So the example is I want to show you that it's a similar, it's a writing, right? And we use this matrix and try to ask, hey, how to ask me the one of particular items for the user 5. And this movie 1. You never watch it. This how to estimate this empty part. So the way we try to do is, okay, we do some neighbor search. We try to identify the movie similar to movie 1 because it is a movie 1, right? And so I want to make sure that, hey, which one? The number 5 have rate only on the movie 3 and also rate on movie 6. So I want to see, hey, which movie are very similar to movie 1 because movie 1, this empty part, the number 5 customer haven't watched it before. So we compare this and compare this. Okay. And of course, you can use a similarity matrix once again. So we can compare 1 and 3 is 0.2, 1 and 6 is 0.3. So it's kind of a 6 is more similar. So we use this information as a weighting, and we consider all of them and provide some averages. I mean, weighted average, say, then try to predict. This one is 2.6 for the customer 5. If you want to rate number 1. Okay, so that's the idea. That's the idea. So we want to do this item prediction. Okay. So we have two ways: items collaborative filter and a user collaborative. Practically, it can be observed. The item are more better for user. just like what I'm using. And why? Because items is simple. User have multiple tests, right? Item means a pair of shoes or maybe compare different books. You could be a little bit easier, right? But the human, hey, how do you describe your personal preference? Usually not easy, right? If you only look at a certain rating, right? So that's why item items more common. Okay, let's talk about the pros and cons of collaborative builder. And you work for any kind of items, yeah. So because you don't need feature extraction selection. I mean, the feature mean here is about items. How do you describe a movie? How do you describe the books? Something like that. But they don't need it. Okay. And but Corsa is an issue saying they need enough users and trying to find a match. So because that's how we call it collaborativity, let other people to help. And the sparsity, yes, the user writing matrix is sparse, and how to find user that have read the same items. So if sometimes you have very very few items, very few writing on that, so it's probably facing trouble. And the first writers cannot recommend an item that have not been previously read. Yes. So if that's a new as well, I'm just a co-star, then probably you will not really recommend. So, for example, you ask a waitress to you go to a restaurant and ask a waitress, hey, do you recommend this is particular dish? And if that waitress never tried it before, then well, you say, I'm sorry, I have never tried this, but I really try this one. I would recommend that one. So that's we call it faster raters. And the popularity bias is cannot recommend items someone with unique text. Yeah, I think that's a very common issues for the recommendation system because you have a very unique, you like a very strange one. You are now I'm not saying strange, but you mean you are unusual, okay, unusual taste, and then it will be easy one. And since based on these collaborative features, you come with compare with other people and other the group of other people, and there might be a huge group, so definitely you will recommend some popular items to customer, right? And of course, then after we introduce the content-based and collaborative filter, then we have the hybrid method. I mean, we combine all of that. So we can implement the two separate recommendation and combine the prediction. For example, one is content-based. You consider that the user profile, item profile, comment, and you can also use the rating to comment. Okay, and so you can even add the content based medical collaborative filters. So for example, you use the item profiles for new items. I think it's a good idea, right? For those new items, new pair of shoes such as long shoes, new laptops that never be purchased before, then you use the item profile to describe it. Also, you can use a demographic to deal with a new customer problem. The new customer, I know nothing about his personal purchase historical information. I don't have that, but I might have chance to know. Maybe you are a college student, and you're female. Maybe I have ideas. Okay, most of the college female students that would like certain things, so that I will still have chance to comment. Of course, after you accumulate a certain rating, and we have more information, we can come in, know you more, right? And how to evaluate the prediction? Well, that's a very common sense. Not well. I'm sorry, it's not really common, but I mean it's very common sense for the people that already learn the data mining or the data scientists. Yeah, basically you want to know your rating and your predicted rating versus your predictive value and what's the difference. Then we have a new mean square error way we are able to uh, calculate uh, And there are some other approach. For example, your one model, we can have a convergency with number item versus user for certain I can make a prediction. And also the coverage means and how many items the customer how many items for that particular thing you can do the predict. And your precision is accuracy about your prediction. And if you learn the data mining, then you probably learn this called receivers operating characteristic, called RC, and you create certain kind of RC curve, something like that. Okay, you try to create the one to evaluate your prediction result. And of course, there are some issues I want to end up. So that, for example, there are problems with majors. Usually, the narrow focus on the accuracy sometimes misses a point. For example, your prediction, this diversity, your prediction is contrast, order of prediction. And that is especially for the recommendation systems. You not really want to recommend something everything similar. For example, I send a message to everybody understand things when you comment that things, and then it's not really what we want to try to do, because well, usually we want to look more detail on the customized recommendation, right? And in practical, we care only the prediction high rating. That's true. Yeah, but Loomis score might penalize the method that didn't well for high rating. They just well for high rating, but very bad for others. So this some of the problems, especially for the measurement. But of course, and today there's introduction courses, and so some of the research paper have been attaching this kind of issue. And some tips. Okay, add data, of course, right? The averages of language data. Don't try to reduce the data size, because we need to have data. So, but there's a fundamental data courses. Some other information I already talked about before that. Larger data is better than small data. It doesn't mean we need a very fancy, very complicated algorithm. But if you have big data, that would be help a lot. A simple method on large data usually do best. I think that's the idea, right? Try to add more data and from other data source. Okay, more data, better hours. That's interesting. Okay, but I already mentioned this in my previous courses. Okay, and how to find similar vectors? A common problem comes with the memory settings. If you got a large amount of vectors, some high dimensional space. I mean, you have very huge data set. You have different each items you want to make sure that pairs of items is usually important. So it would be correlated to user profile and then profile. Okay. And also there are some other issues is how to do the near neighbors research in high dimensional data. High dimensional data is a little bit tricky. So it's also a very important question. All right. I guess I already cover the fundamental knowledge about recommendation system. As you know, the more important concept I wanted to keep that you learn is we have a one way called content based, and we have another way is called labelability filter. And some of calculation is based on the similarity, TF-IDF. TF-IDF is because we have a document-based items to describe the items, right? And we have if you have a rating, then no matter how you get the rating, maybe you can in practice get the rating from 0 to 5, or ask customer to give, and maybe you use some kind of another data processing to find the rating, to predict the rating, and then use a predicting rating to know if a customer would like it. You definitely want to recommend the high rating item to the customer, right? So that is a certain way we use for create the recommendation system. But sooner or later, I will ask you to provide you one of a set of code. You are able to practice on the real world example of movie recommendation data. So that's why I want you to try. Okay, I would like to end this section. Okay, I will probably give you like a 10 or 15 minutes break. Please go take some break, and to make sure you come back in like I think it's a 10:50. All right. If you can come back on 10:50, I would like you to work on the Spark of setup, and I want to go through that setup and to describe it, and you are able to practice on real world data. Okay, let's take some break. Okay, I will start a recording. I want to call next. Okay.